In this session, we will mainly discuss about the memory system of the computer. Memory system, a typical term. When we were discussing about the structure of the computer, we talked about one particular term called main memory. Main memory, which is extremely important for any computer system, and at that time we pointed out that here is a memory where data and instructions are to be stored, and CPU constantly fetches instructions and executes them. The instruction as well as data, to be more accurate in that particular context. So first let us look at the basic characteristics or basic points relating to the main memory. The main memory, as I told you, stores program. It also stores data. Another important characteristic of the main memory is that it has an address. The basic point about the address lies that memory is considered to be a sequential array of memory locations, and each memory location then can be used for storing data or instruction. To be more precise, an instruction in the main memory is treated as data only. However, that is a typical data which, when it is fetched by the CPU, is interpreted to be an instruction. The other characteristic of term which is associated with the memory is that smallest identifiable unit in the memory is word. In fact, word is one of the most ill-defined terms in computer science. Word sometimes is defined using memory word, sometimes it is defined using the processor technology or the CPU. But for our sake, for our discussion's sake, we will stick to the term word as the memory word. And word is basically the length of the single identifiable unit in the memory. Word basically consists of binary digits, and 8-bit consists of 1 byte, and a word may consist of 1 byte, and this kind of memories are called byte addressable memories. Word may consist of 16-bit, word may consist of 32, 64, and so on and so forth. But the important property which we can visualize, if our memory unit is addressable at byte level, then that particular memory unit is called byte addressable memory unit. Another important characteristic which goes with the main memory is that it is slower than the central processing unit of the computer. Now this is an extremely important criteria. If the memory is slower than the central processing unit, and since it is involved at each and every step of execution of the instruction, that is, for executing an instruction, we got to fetch an instruction from the memory, fetch the operands from the memory, and then execute it. That simply means probably 50 to 60% of the time, CPU is involved in fetching something from the memory, maybe instruction or data. In that context, if memory is slower than the central processing unit, then central processing unit cannot execute to its full potential. That means you are wasting the capabilities of central processing unit. So what is the solution? The solution is very simple. The simplest of solution possible in this particular case is we make main memory of the memory technology which central processing unit is, that is the semiconductor memories. But unfortunately for us, the technology is very expensive. So what do? In that context, this particular terminology is basically called cost versus speed anomaly in memory system. What is that? On one side, if we want to have better computer performance, we have to allocate more memory, but more memory is costly. Okay, so these two are the contradictory things. How to optimize? Probably we have to do something which already exists in computer, or probably we have to find out some characteristics of the program for implementing such a thing. And what we say in this particular context, that if a program is executing, it is highly likely that the next instruction which is to be executed will be closer to the current instruction. In that context, what we are basically assuming that program behaves in such a fashion that most of the addresses are closer or local to each other. If that is the case, then can we have a system of the kind where we can have CPU registers at the top, which basically I told you earlier also that these CPU registers are mainly involved when an instruction is being executed, and these are intermediate storage locations. So there must be some locations as far as intermediate locations are concerned, and this memory capacity cannot be infinite because the space requirement of this memory is quite high if it goes to CPU. The other possible solution came in the form of a fast memory whose size is more than the CPU register but considerably less than the main memory of the computer, and that memory was logically placed between the CPU register and the main memory and is called cache memory. And finally, since main memory shows certain characteristics such as it loses its content once the light is switched off, we require a permanence of storage, a permanent storage capacity of very high degree, and that particular memory is called secondary memory. So we have a kind of memory hierarchy where the cost is going down from top to bottom. However, the storage capacity, as block size you can see, the block size is decreasing as we are moving towards the top of it. And this is basically is termed as the memory system of the computer. But if that is the case, that is, the size is continuously decreasing from the main memory to the processor register, then the question comes, we cannot store the complete information and data, in fact instruction and data, which is stored in the main memory into the cache memory. So what do? Here the principle of locality, which I just explained to you, come very handy. That is, whatever instruction is being executed, the instructions and data closer to it is put into the cache memory and remaining resides in the main memory. And whenever new information or data is to be put, that particular whatever space has been utilized by those instructions in the cache memory is written back to the space from where the required instruction or data was taken to the cache memory, and newer amount of information is taken back. So this is the way we try to sustain faster memory to CPU data transfer cycles, whereas we do not compromise very highly on cost. So this is basically a sort of compromise, considering keeping cost down, on the other hand keeping cycle time or execution of CPU at the faster pace. Let's talk something extra about the main memory, some more things about the main memory. We have discussed about CPU registers. We will not take up in more details as far as CPU registers are concerned. Cache memory, I have given you pointers. We will talk a bit about them slightly in details later on also. But let us focus our attention to the main memory and its characteristics. And the basic characteristic terms which comes with the main memory are, the first is random access memory. Take a situation of a classroom where 20 students are sitting in front of me and I want to select one student. What I can do, if I remember their name, simply I have to tell their name. Mr. So-and-so, Mr. X, please stand up. And that's it. The amount required for that particular thing is constant. I can do it for Y, I can do it the same thing for Z in constant amount of time. Similarly, with the main memory, what exists is an address. If I specify the address, the amount of information or whatever information is stored in that particular location should be accessible to me in same amount of time, irrespective of the location specified. And that is the concept of random access memory. The second concept which goes over there is read-only memory. Fine, random access is fine, but there are some programs into the computer which we want to simply read only. We don't want to write on those locations. They are important programs designed by various computer programmers, experts in that particular area. We don't want to destroy those programs at all. And those kinds of programs can be stored in RAMs, which are read-only memories. Remember, access to RAM is also a random access. However, only thing which is missing in RAM is that you cannot write to that particular location, whereas in RAMs you can read as well as write. The third characteristic is volatility, that is volatile and non-volatile memories. I think the concept should be very clear to you. Volatile is memories which loses their content as soon as we switch off the power. For example, the main memory. And non-volatile are the memories which do not lose its content. For example, magnetic storage devices. The next important term is destructive and non-destructive readouts. There are certain memories which on reading loses their content. In fact, the reading process destroys the content of those memories. Okay. Now, these kind of memories are to be written back. As the data is being read, it is to be written back. That means they require added circuitry for writing once again immediately. Another important characteristic is static and dynamic memory. I think this is one of the most important characteristics of a memory. Static memories are those memories which are based on flip-flop technologies, whereas dynamic memories are based on something called capacitor kind of technologies. What does that mean? The simple thing is the way to understand this particular thing is, suppose take a capacitor. What happens with that capacitor? Even if power is on, that particular capacitor keep on losing its power slightly, gradually. And there comes an instant when the whole capacitor is discharged or is not containing any memory information. The same thing happens with the dynamic memories. The dynamic memories loses their content even if power is on. If such is the type of memories, then what these kinds of memory require? Some kind of circuits which periodically refresh the memory. That is, if there is one stored in the memory location, it has to be refreshed in a sense but one is stored there all the time. And that particular process is called refreshing of dynamic memories. What about static memories? The static memories, as I told you, are flip-flop based. That simply means that these memories will never lose its content. They will remain whatever the content they used to have. They will remain at the state they were earlier. The basic advantage of static memory over dynamic memory is that the static memories are faster than dynamic memories. Why? For the simple reason that for static memories, no refreshing is required. If no refreshing is required, no refreshing circuitry is required, no time is wasted for refreshing. However, there is a major drawback with static memory, and that major drawback is that they are more expensive. They cannot be packed as densely as dynamic memories can be. That simply means the dynamic memories can be packed more densely. And today's most of the computer technologies in the main memory are using dynamic memories, because the more bits you can pack in a chip, the costlier or less costlier the particular chip is going to be. The disadvantage, once again, is the access time. Considering that particular thing into consideration, today what is done, that main memory is normally made of dynamic memories called DRAMs, and cache is normally made of static kind of memories called SRAMs. Today's processors, in fact, are built with some kind of cache memory inside. So the question comes whether we still need cache memory outside or not. The answer is yes. Even if today's processor is having some built-in cache memory, if you can provide some extra cache externally, that always helps in increasing the speed of the processor to some extent. However, the newer kind of memory technologies which are coming up as far as DRAMs are concerned, which are some kind of called EDO RAMs and that kind of memory technology. In those memory technologies, the static component is inbuilt into the dynamic RAMs. That is, a very small area of dynamic RAM is built as static RAM, which is interfaced to the processor. The advantage is that in the main memory, we are making a sort of cache memory. All right. So that particular kind of atmosphere or that kind of a situation helps in increasing the processor to memory data transfer at a very fast rate. In fact, it is said that these kinds of RAMs can be easily utilized at the expense of having extra static RAM or cache memory which is placed between the main memory and CPU processor externally. So these internal cache memory inside the processor as SRAMs and over here inside the DRAMs can offset the cost of some kind of static RAMs or cache memory to quite an extent. So today what we are looking at is some kind of main memory which contains dynamic as well as static capabilities. The final term, access time, I think I have referred to this particular term quite often. And access time, once again, what we are looking at, our basic objective is to bring in or to reduce the access time to its lowest. And that's why we are looking in for all kinds of memory technologies, mainly cache, high-speed main memories, and so on and so forth. The final term in memory system, which is of extreme importance for you, is the auxiliary or secondary storage. Auxiliary and secondary storage devices are definitely slower, but the characteristics of them, that is permanence of storage, is of extreme importance to us. Auxiliary, there are many auxiliary or secondary kind of storage devices. Some of those which you might be already knowing about, for example, magnetic tape, magnetic disks, okay, floppy disks, CD-ROMs, all these are under the broad purview of what we call secondary storage devices. One of the earliest secondary storage device was magnetic tape, and I would like to show that magnetic tape to you, and you can see by yourself that this particular magnetic tape is too big in size. All right, you can compare my hand size and this tape size. So imagine that it is too big. And what it used to store, what today the small cartridge of this kind, okay, can store. The memory capacity is almost identical for this small cartridge tape in comparison to the tape which we had earlier, that is this big tape. So you can see the size difference, whereas there is no difference as far as capacity is concerned. These magnetic tapes are almost outdated today. And what is the in thing? This cartridge tape. But the basic reason why these cartridge tapes are not used for storing programs and other kind of information is basically these cartridge tape provide some kind of serial or sequential kind of access. Compare it with your tape recorders, cassettes. If you want to listen to the next song, you got to move one song ahead. The same applies here. If you now want to move to next program, you got to move the whole tape till the next program arrives. This kind of a drawback is offsetted by something called magnetic disks. Look at the magnetic disk of this kind, all right, very small. However, what advantage this disk gives us, that it allows us random access. In fact, the word is not random access, the word is direct access. And most of the time people are confused with that random access memories is this particular thing. Frankly speaking, it is not random access, and it is called direct access. What does it mean? This particular term I will explain to you at a slightly later stage. But before, let us look at the various components of this particular floppy disk. And one of the most extremely important component of this floppy disk is this notch, which is called write protect notch. Remember, this is the notch. If you protect it by write protection tab, this is the notch which will not allow virus to come into your system. This, you might be already knowing, read-write kind of head is fixed at this particular location. This particular area goes into the drive and helps in rotation. Over here is something called index hole, which basically indicates the starting location and so on and so forth about this particular floppy disk. Let us look into the basic construction of this kind of a disk, or the format of this kind of a disk. And what we say, sector and track based format. Okay, a sector, and this whole thing, whole circular thing is called a track. So a sector track based concept. And what happens? Read-write head moves in these particular directions. All right. So the read-write head can access any sector. So there might be more sectors, or what we say tracks of this kind. There might be many more tracks of this kind. And once you have moved to the required track, okay, then you read a required sector. Okay, and that sector basically can come after a rotation. Since disk is rotating, so it will come at some point of time below the head. So in that particular sense, if you are reading a sector on a track, it is some kind of sequential access, whereas once you are moving the arm, it is a kind of random access. And that is what we say a direct access kind of a device. Finally, one of the most important secondary storage device, which is of extremely importance for you for today's systems as we are moving towards multimedia system, and that is what we call CD-ROM. Here is a CD-ROM which is extremely important for you. Look into the kind of shiny surfaces it has, very shiny. Okay. What I would like to talk about CD-ROM is the basic advantages of this technology. The very first advantage is it is a mass storage optical device. That means somewhere around 640 MB can be stored onto this small device. The second advantage, it's a portable storage device. The basic problem which lies with your hard disks is that they cannot be ported, whereas CD-ROM can be ported. The third advantage is storage capacity is high, which we have already talked about. Books, journals, abstracts, etc. can be published on CD-ROM, which is extremely important in today's multimedia environment. It allows faster searching, smaller storage space, and can support multimedia experiences. Now this kind of technology, it is, so much of storage space and still portable. The problem with the CD-ROM is that you cannot write onto it. Once you have stored some information, that is it. But today's CD-ROMs, the new kind of CDs are coming up, and they are already available in the market, which are writable also. So that will give you some kind of mass portable storage device. Okay. So with this, I would like to sum up this particular session. And what we have covered in this particular session, we have discussed about the importance of having memory system. We have discussed about the various characteristics of main memory. We have discussed specifically about dynamic and static RAMs, which are basically used in cache memories. And then we have discussed about the auxiliary or secondary storage devices. Bye for now. Thank you.